Lesson 5-1. For this lesson, you need a compass and you need a ruler. We're going to use our compass to construct a perpendicular bisector of side AB. Perpendicular, remember, means 90 degrees, and bisect means to cut it in half. So we're going to cut this side in half just using our compass and our ruler without measuring it. First thing you want to do is place your compass on the vertex of side A. Then you're going to adjust it so that it is a little more than halfway the length of AB. So I see that that's more than halfway. So I'm going to lock it in. And I'm going to use my pencil to make little marks. Like that. I'm going to do the same thing. I'm going to leave it. Don't adjust your compass. I'm going to put it on angle B. And I'm going to use the same hole. Okay, so if you need to, you may need to go back to side A like I need to and extend it a little further so that you can tell where they cross. You should be able to see that they make two places where they cross. They cross right here and they cross up here. This is where you're going to take your ruler and just use it as a straight edge and connect them. Okay, this side right here is now perpendicular and it cuts AB in half. It is exactly in half. You can even measure it. If AB measures about 6.5 centimeters, halfway is 3.4. Next, we're going to construct an angle bisector through angle A. An angle bisector means it's going to cut our angle in half. So we're going to use our compass again, and we're going to draw an arc. So we're going to put it on vertex A, and I put mine all the way to the end because it's kind of a small triangle. And we're going to make an arc just on the sides of the triangle like this. We're going to keep our compass where it's at. We're going to use the same holes, and we're going to place the compass on this first tick mark, and we are going to swing it over here, somewhere in the middle. We're going to do the same thing on this tick mark. We're going to place it, use that same hole, and just swing it towards the middle. And you can see that they cross each other right here. If I connect that point to angle A, the vertex, I get an angle bisector, an angle that is cut directly in half. It forms two congruent angles. We're going to use those to talk about bisectors, both perpendicular and angle, in lesson 5-1. Example 1 says to find each measure. So I want to find side BC, this side right over here. I notice that this right here is a perpendicular bisector. Since it is a bisector, it cuts my triangle in half. So BC is going to be the same measure as AC. 8.5. Letter B, I want to find the measure of XY. This side right over here. I have a perpendicular bisector again. It bisects side XZ. Since it bisects it, I know that YZ is the same as XY. So XY is also 6. Letter C, I need to find the value or the length of PQ. I know that since this is a perpendicular bisector, PQ is going to be congruent to QR. So let's set up our equation. 3x plus 1 equals 5x minus 3. Let's solve for x. Okay, x equals 2. Is that what I wanted to know? Not quite. I wanted to know the value or the length of PQ. So I need to substitute it in. So let's take 3, and instead of x, we're going to put 2 plus 1. We'll take the equation that's given to us, plug in x, and let's evaluate it. We find that PQ equals 7. Okay, number 2. We have a new word in number 2 called circumcenter. This word right here, the circumcenter, what that is it's the place that all of your perpendicular bisectors meet. So your perpendicular bisector of XY, ZY, and XY. If they were all to meet, where would they meet? You need to know that if it's an acute triangle, the circumcenter is in the middle or the interior of your triangle. If your triangle is an obtuse triangle, your circumcenter is actually outside the triangle. And if your triangle is a right triangle, your circumcenter will be on the triangle, like on a side. So my question wants to know, can a fountain be placed at the circumcenter, the place where all the perpendicular bisectors meet, and be in the garden? If this is my garden right here, I want to know if it's going to be on the inside. So first of all, what kind of triangle is triangle XYZ? Is it acute, obtuse, or right? Yes, it is obtuse. Since it's obtuse, my circumcenter is going to be outside, probably somewhere over here. So will it be in the garden? Nope. So let's explain. No. Why? Because the circumcenter of an obtuse triangle is outside the triangle. This is on page 324 in your book if you would like to reference circumcenter. Okay, let's talk about angle bisectors. Anytime an angle is bisected, it means that it is cut equally in half. It forms two congruent angles. For example, angle A has been bisected. I know that because I have these marks that tell me that those are two congruent angles. When an angle is bisected, we have these little lines over here, And those are also going to be congruent because of the angle bisector theorem. So if DC is 5, how long is BD going to be? 5. Excellent. Letter B. I want to know the angle or the measure of angle WYZ. This angle right here, WYZ. Now, I don't have marks on this one to tell me that the angles are congruent, but I do have marks on the sides up here to tell me these are congruent. So using the converse of the angle bisector theorem, I know that YW is an angle bisector. So these two angles are congruent. If XYW is 28, that means WYZ is also 28 degrees. Letter C, I want to find QS. So I want to find this side right here. I know that I have an angle bisector, which means QS is congruent to SR. So let's make an equation and find X by setting them equal to each other. 4x minus 1 equals 3x plus 2. Let's go ahead and solve for X. Okay, so I know X is 3. Is that what I wanted to know? Nope, I need to know how long the side is. So let's plug it in place of X. 4 times 3 minus 1. QS is 11. Very good. Last example, we have another new word, incenter. So we had circumcenter, which is the place where all the perpendicular bisectors met. Incenter is the place where all the angle bisectors meet. So this angle right here is congruent to this angle. That means this 31 degrees, this angle over here is also 31. And then these two angles in the corner, angle P, those are congruent to each other also. It's where they meet. The incenter theorem, which is on page 326, also tells you that each of these perpendicular lines, even though they may not look it, they are congruent. So what we want to know in letter A is the value of SU, this line right here. If I were to focus only on this triangle, I see a right triangle. I have two of my sides that I know, a leg and a hypotenuse. What theorem do you think I could use to find this other leg? Pythagorean theorem. So let's write it out. X squared plus 8 squared equals 10 squared. Let's go ahead and simplify. X squared plus 64 equals 100. Okay, let's subtract 64 from 100. And we'll get x squared equals 36. To solve for x, don't forget you're going to take the square root of both sides. Square root of 36 is 6. So SU is 6. Okay, the other thing we want to find is the measure of angle SPU. SPU. Alright, we need to do a little bit of filling in the blanks here. Okay, don't forget I told you that these angles are congruent. So if this is 28, this is 28. If this angle down here is 31, this angle right here is 31. Okay. I see a triangle right here, NRP. And I see that this right here is perpendicular, which means the other side is also 90. There are 180 degrees in a triangle. So angle P has to measure 180 minus the sum of 28 and 90. How big is angle P? If you got 62, you're right. Now 62 degrees is for this whole angle, that big one. I only want to know SPU, half of it. It bisects it. So what I need to do is cut it in half. What is 62 divided by 2? 31. SPU is 31 degrees.